There's two things that I want you to think about with regards to what I'm going to ask you to do right now. One is, this is an opportunity for you to self-check. The key here is, this is all information that we've gone over before. But it's not a task that I've asked you to do before. It's one that I've alluded to, and it's one that you have actually seen in like problems in the book. It's not like it's not a completely new scenario or a completely new problem. But I haven't asked you to do this particular thing in class before. But this really gets at the heart at what I'm trying to help you learn in physics, which is, if I stand up here and I show you, here's how you can use a supercard to find the velocity of something, then everybody can do that. And if I tell you, here's how you can use this force sensor to measure the force on something, then everybody can do that. But what I want is for you to take all those skills you've learned, combine them with an understanding of the principles of physics, the basic rules of physics, like the kinematic equations and Newton's laws and things like that, and use that to be able to do things that we haven't done before. That's the real key. That's what makes this class so much different from your other classes. It's not just, here is a problem, learn how to solve it, and then I'm going to ask you to solve it on a test. It's, here are some principles. Apply those principles to a unique situation. That's the real skill. That is the big skill that we're working on. We haven't really done it yet. We haven't done it yet. Everything we've done up until now has been me showing you how to do something and then you doing it. I showed you how to use tracker to find initial velocity and acceleration, and then you use tracker to find initial velocity and acceleration. I showed you how to make a prediction for the distance of a horizontal launch, and then you did that. I showed you how to make prediction for distance for an angled launch, and then you did that. I asked you on the final lab for projectile motion to look for a couple of things that we hadn't done before. What happens if it's not landing on the ground, but we want it to go into a bucket instead? What happens if we want to put a hoop some distance away from the launcher? But I even showed you how to do those, because there was a homework problem that lined up with that perfectly, right? The problem where they were shooting the t-shirt into the stands, and there was a person who was going to catch the t-shirt. That right there was both the hoop and the bucket at the same time. We had both of those scenarios involved in that problem, and I showed you how to solve it both ways. So everything we've done up until now has been me telling you, here's how you do it. Today we're going to start something different. Today we're going to start where I'm going to give you the rules, and then I'm going to ask you to solve a problem, and your response is going to be, how? You don't know how. I'm not going to tell you how. I will work with you, and I will get you there. I will guide you, but ultimately what I really want is for you to be able to apply what you know to solve the problem. So that's what we're going to be doing here. So part of what's going on is this is a review of stuff that we've already done. There's nothing new here. But part of what we're doing is a new skill, and it is the most complicated skill that we're going to work on all year. We're going to work on it all year. This is going to characterize everything we do from here on out, which is, how well can you use principles of physics to solve real problems. And this particular problem is going to be one where I'm going to kind of lay out the parameters for you. Other kinds of problems, there might just be a question. A question like, how fast is something going? Or what is the force acting on something? Or what direction will it move? And we won't have done a bunch of practice problems that lead you to that. It's going to be, you're going to be like figuring this out from the principles of physics, okay? So here is the scenario. You're gonna have a cart, this one right here. And you're not actually gonna do this, I'm sorry, let me be really clear. But the scenario is, we have a track, and we have a cart, and you have two pieces of equipment. You have a stopwatch, and you have a ruler or a meter stick. And the ramp is tilted, and my question to you, the question that I would want you to be able to answer with this equipment is, what is the acceleration of the car as it rolls down the ramp? How would you find, or how could you find the acceleration of the car? And what I want you to do is explain to me exactly what you would do. The measurements you would make, the calculations you would make. You don't necessarily need to explain why those things might work, although if you really understand the concept, you should be able to do that. You can, if you want, you can look at your notes, but don't use the internet, don't use Google, don't use any of the stuff that I've provided to you. Just use like what you have written down and what you know. And I don't want you to talk to each other. I want this to be entirely independent. I want you to do this on your own, on a separate sheet of paper. I want you to turn it in about 10 minutes, and this is not gonna be part of your grade, okay? There's two reasons we're doing this. One is to review kinematics, because that's what this is. This is a kinematics question. The other is to think about this new skill. We have not done this problem. This right here is one of the most basic physics questions. How can you find acceleration with a ruler and a meter stick? That's all you've got, a ruler and a meter stick, okay? Sorry, I meant to say a stopwatch. A stopwatch and a meter stick. So you can measure time, you can measure distance. That's it. Tell me how you're gonna find displacement, okay? Or tell me how you're gonna find acceleration, okay? So do it without talking to each other. If you start talking to the person that you're next to, I'm gonna move you. Not because I think you're cheating, I don't know what you're talking about, but because this won't be useful to you if you are relying on your team. You don't have a team to rely on here, okay? So I want you to do this utterly, completely on your own. And if you can't do it quietly next to the person that you're sitting next to, then go somewhere else so that you can do it then, okay? So everybody should have paper, pencil. You don't need a calculator because there are no numbers for this. You're just gonna tell me what you would do to find the acceleration.
We're supposed to have the kinematics equations memorized?
You can use your notes.
Oh, okay.
Yeah.